Alright, in this video we're going to take a look at how to solve an example of a 3 by 3 system of equations with one solution. So here we have the equations x plus 2y plus 3z equals 6, 2x plus 5y plus 2z equals 4, and 6x minus 3y plus z equals 2. So we're going to find the ordered triple, I should say, x, y, and z that will make each equation true. Now we're going to use the elementary row operations that we discussed in the last video and in the last section. And truthfully, if you still feel a little bit uncomfortable, go back and watch the 2 by 2 systems of equations until you get comfortable enough with them, because if you understand the 2 by 2 system solving using elementary row operations, the 3 by 3 is just an extension of that. So rather than try to understand all this at once, make sure you have a solid understanding of the 2 by 2 system of equations and the row operations. So the first thing we're going to do is we're going to write the augmented matrix using, so let's see how the penmanship holds up. So we have 1, 2, and 6, 2, 5, negative 3, 3, 2, 1, and there's our equal signs represented by the vertical bar, 6, 4, and 2. Okay. So our goal, once again, is to get this first number in this first row equal to 1, which it is. If it's not, then we can see if we can switch it with another row, or we'll just have to divide everything. But it is, so that's good. So now we want to get the values below that 1 equal to 0. And for the second row, we're going to take the opposite of 2, which is negative 2, and multiply row number 1 by negative 2, and then add it to row number 2. So we're going to take negative 2 times row number 1, add it to row number 2, and that's going to be our new row number 2. So just like we did with 2 by 2 systems of equations, except now we have a third row. For the 6, we want to take the opposite of 6 is negative 6, so negative 6 times 1 plus row 3, and that'll give us our new row 3. So negative 6 times row 1 plus row number 3, that's a 3, and that'll be our new row number 3. All right, so let's see what we get. Well, the first row, we're not going to change the first row at all, so we can just copy that down. I'll give myself a little more space. So we got 1, 2, 3, and equals 6. All right, so negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Negative 2 times 3 is negative 6. Negative 6 plus 2 is negative 4. Negative 2 times 6 is negative 12. Negative 12 plus 4 is negative 8. All right. Now, negative 6 times 1 is negative 6. Negative 6 plus 6 is 0. Negative 6 times 2 is negative 12. Negative 12 plus negative 3 is negative 15. Just got to be careful with calculations here. Negative 6 times 3 is negative 18. Negative 18 plus 1 is negative 17. And then 6 times negative 6 is negative 36. Negative 36 plus 2 is negative 34. All right. And just like the 2 by 2 systems of equations, once we set this first column to have a 1 and then 2 zeros below it, all the other row operations we do should not change this first column. All right, so now let's move on to the second row, second column. And good news, that's a 1. So that's really good to know because we don't need to do anything to get it equal to 1. So we need to get the value above it and below it to be 0. And once we got it equal to 1, it makes it easier. So if we take the opposite of 2 is negative 2, if we take negative 2 and multiply it by this 1, multiply it by row number 2, we can add it to row number 1 and get a new row number 1. Likewise, below the 1, we have negative 15. If we take the opposite of negative 15, that's positive 15. So positive 15 times this 1, or positive 15 times row number 2. We can add that to row number 3, and that'll give us a new row number 3. All right, so let's take care of that. Again, the second row is not going to change in this step of the problem. So we can just copy the 0, 1, negative 4, negative 8. So 0, 1, negative 4, and negative 8. All right, so for the first row, we're going to take negative 2 times the second row. So negative 2 times 0 is 0. 0 plus 1 is 1. So again, remember, that first column is not going to change. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 4 is times negative 4 is positive 8. Positive 8 plus 3 is 11. Got to be careful with calculations. Biggest mistake people make. Negative 8 times negative 2 is 16. 16 plus 6 is 22. And now let's work on this last row. So we have 15 times 0 is 0, plus 0 gives us 0. Again, that first column's not going to change once we got it set. 15 times 1 is 15. 15 plus negative 15 is 0. So there's our second column set. 15 times negative 4 is negative 60. Negative 60 minus 17 is negative 77. Yikes. All right. And then, let's see, we have 15 times negative 8 is negative 120. Negative 120 minus 34 is negative 154. So some large numbers there. But at least we got the second column set. All right, now that we worked on the second row, second column, we can work on the third row, third column. So we can get this value here. Now, this time it's not equal to 1. So if we divide the third row by negative 77 or multiply the third row by 1 over negative 77, either one's fine for me. I'm not going to be picky. But that should give us a 1 here. So if we take the third row and we divide it by negative 77, which is the same as multiplying by 1 over negative 77. And we can store that as our new third row. So let's do that. All right, so we get 0, 0, negative 77 divided by negative 77 is 1, and negative 154 divided by negative 77 is 2. And we haven't done anything with the other rows yet. Keyword yet. Hopefully the penmanship isn't too poor. I apologize if it is. All right, so we got this value equal to 1, which is good. That's what we needed. So we got this equal to 1. And now we want to get the values above it equal to 0. So again, the idea is if we take the opposite of 11 is negative 11 and multiply this 1 by, or multiply that negative 11 by this 1, so negative 11 times this value, which is in row number 3, and we can add it to row number 1, that'll be our new row number 1. So negative 11 times 1 plus 11 will give us a 0 here. Likewise, negative 4, the opposite of that is positive 4. So if we take positive 4 times this 1 and add it to negative 4, that will cause this to equal 0 as well. So that's the advantage of getting it equal to 1, because then you can just look at the number that's above or below it and take its opposite. So if we take 4 times row number 3 and add it to row number 2, we can make that our new row number 2. And it just takes the practice of getting used to that. Once you get the hang of it, it's pretty much the same pattern. It's pretty algorithmic, as they would say in very, very upper level classes. So again, we know that this is going to keep these columns as they are. So, I mean, after a while, you get so used to it that you don't even bother worrying about it anymore. As far as doing the 0 times, negative 11 plus the 1 and all that. So, all right, but we're going to take negative 11 times 1 is negative 11. Negative 11 plus 11 is 0. And then negative 11 times 2 is negative 22. Negative 22 plus 22 is 0. And then 4 times 1 is 4. 4 plus negative 4 is 0. 2 times 4 is 8, and 8 plus negative 8 is 0. So notice that we have, to the left of this vertical line, we got the 1s on the main diagonal and then 0s elsewhere, which means our answer for our x-coordinate, whoops, I knew I would do that eventually. Always do that. Our answer for our x-coordinate, which I thought I had it selected with red, is this 0. The y-coordinate of our intersection is 0, and the z-coordinate of our intersection is 2. So it's not an ordered pair because we have 3 variables. It's an ordered triple. So 0 for x, 0 for y, and 2 for z. So those 3 planes intersect at that point. Or if we made vectors out of each of the columns for I hat, j hat, this would be k hat. We would need no I hats, no j hats, but we would need 2 of these k hats in order to get to the point 6, 4, and 2. So you can use that as well. But 0, 0, 2 is our final answer. So we'll do another example in the next video. So I will